Here we have four inequality symbols. The first is less than, then we have greater than, then less than or equal to, and greater than or equal to. This statement is read 2 is less than 3. 2 is less than 3. Now this symbol, this less than symbol, is designed so that it has a smaller side, that's the pointed side, and opposite it has the larger side, the open side. So the smaller number is next to the smaller side, and the larger number is next to the larger side. All right, so this reads 2 less than 3. In number 1, we have an inequality that reads x is less than 8. So x is a number that's smaller than 8. Let's just write down some possibilities for x. Well, x can be, let's say, 5, 6, or 7. Or x can be negative 100. Or x can be 7.9 or 7.999. Anything to, less than 8. And now what we'd like to do is graph all numbers that are less than 8. So what we're going to do is we're going to graph these on a number line. So let's draw a straight line, and we'll place 8 on the number line, and then we'll put in some other values as well, like let's say 5, 6, 7, and let's say over here we have maybe 5.5. Basically anything to the left of 8 will be less than 8. So let's shade in that part of the number line that's to the left of 8. We're just going to shade it in. And then to indicate that anything to the left of 8 is included, we'll put an arrow, meaning the shaded area goes on forever, to make sure we include numbers like negative 100. But what about 8 itself? Well, 8 is not less than 8. So at 8, we're going to put an open circle just to indicate that 8 is not included. 8 is not included in the shaded area. So this is a graph that represents this inequality, x less than 8. In number 2, we have the inequality x greater than or equal to 5. So let's start by, first let's start by writing down how this is read. So it's read x greater than or equal to. Notice the or equal to, and that's because of this double line over here. In other words, x can be equal to 5 this time. Let's write down some possibilities for x. Numbers that are greater than or equal to 5, like let's say 6, 7, 8, and let's say 100, and let's say 7.5. All right, and let's say 5.1, and also 5 itself, because 5 is equal to 5, so 5 is included. All right, let's draw a graph on the number line of x values that are greater than or equal to 5. So here's the number line. We put 5, we marked where 5 is, and maybe we'll mark just a few other values, say 6, 7, and 8. And maybe here we'll put in, let's say 5.1. So basically all numbers to the right of 5 are greater than or equal to 5. So remember, greater than to the right, less than to the left. All right, so let's shade in the number line to the right. And we'll put in a little arrow indicating that the shaded area goes on forever. Now this time we want to include 5. So what we're going to do is we're going to put a solid dot where 5 is. We'll color in that dot this time. All right, so this solid dot is because of the double line here, the greater than or equal to symbol. And this is the graph of x greater than or equal to 5. In number 3, we have an inequality, and we want to solve for x. That is, we want to get x by itself on one side of the inequality symbol. So we're going to solve inequalities almost the same way we solved linear equations. That is, we're just going to isolate x using basic operations, adding to the same thing to the both sides, or subtracting the same number from both sides, or multiplying or dividing. But we have one extra rule, and here's the rule. When you multiply or divide both sides of an inequality by a negative, you switch the direction of the inequality symbol. Okay, so that's only when we're multiplying or dividing by a negative. All right, so now let's solve this simple inequality. It says 5x greater than minus 15. So we're going to divide both sides by 5. All right, now we're not dividing by a negative. We're dividing both sides by a positive 5. So this rule does not apply. And we get, just like one would expect, we get x greater than minus 15 divided by 5 is negative 3. X greater than negative 3. All right, number 4, we have the inequality negative 5x is less than 40. So we're going to divide both sides to get x by itself. We're going to divide both sides by negative 5. All right, and now we are dividing both sides by a negative. So here our rule does apply, and right away we're going to switch the direction of this inequality. Okay, so the negative 5's cancel on the left, and we get x is greater than 40 divided by negative 5 is negative 8. X greater than negative 8. All right, in number 5, we have an inequality that we're going to solve the same way, pretty much that we solve an equality. Just keep the rule in mind in case we need it. All right, so we'll start by isolating the x term, add 4 to both sides. And we have 3x greater than 15, 11 plus 4. And now divide by 3. And we have x greater than 15 divided by 3 is 5, x greater than 5. All right, so here we did not have to switch the inequality symbol. We divided both sides by a positive number, not a negative, so the rule did not apply, and we solved this just the same exact way we would solve a linear equation. All right, in number 6, we're going to solve. Keep in mind we want to isolate the x term. So the x term has a plus 2 next to it, so let's subtract 2 from both sides, get rid of that plus 2. So let's bring down the minus 3x. And here we have negative 10 and another negative 2, that's negative 12. And so now we want to isolate x, get rid of the negative 3 that's multiplying it by doing the opposite of multiplication. We're going to divide both sides by negative 3. Okay, so here we are dividing both sides by a negative. So the rule applies. So we're going to switch the direction. All right, and we get x by itself on the left is greater than or equal to negative 12 divided by negative 3 is positive 4. X greater than or equal to 4. In number 7, we have 2 x terms on both sides of the inequality symbol. So we want to start by gathering together these x terms. So we'll start by subtracting 3x from both sides. So here we have 2x minus 3 is greater than 7. And now we want to isolate the x term. Let's get rid of that negative 3. Let's add 3 to both sides. So we have 2x is greater than 10. And now finally, let's isolate x. X is being multiplied by 2. Let's divide by 2. And we have x is greater than 5. Number 8, we have to be careful. We want to gather together the x terms, but we also want to eventually isolate the x term, get x by itself. So it's most efficient to subtract 3x from both sides, then we'll have only one x term on the right and we'll have a number on the left. So let's do that. Let's subtract 3x from both sides. So here we're left with 12, and here we're left with 3x. So the x term is isolated. And just one more step, divide by 3, and we have x greater than or equal to 4. Now notice that this is considered written backwards. If x is on the right, it's considered written backwards because we read left to right. And here, if we start reading starting with x, we're going to read this right to left. This says x, this is greater than or equal to, because x is on the larger side. X is greater than or equal to 4. 4 is on the smaller side. So what we're going to do is we're going to write this forwards. We're going to put, we want to have x on the left and 4 on the right, and we want it to read the same way this does. We want x to be on the larger side and 4 to be on the smaller side, the pointed side. Okay, so this, again, this reads x greater than or equal to 4. So we prefer, this is the preferred form of the inequality. All right, so that we can read it left to right, x on the left and the number on the right. In number 9, we're going to start by gathering together the x terms. Let's subtract 4x from both sides to do that. So here we have negative 2x, and bring down that minus 5. Bring down the greater than or equal to symbol. These cancel. And we have 7. Now we want to isolate this x term. So let's get rid of the minus 5. Let's do plus 5 on both sides. So we have minus 2x on the left, greater than or equal to, and 7 plus 5 is 12. And now we're dividing both sides by negative 2 to isolate x. All right, now this time we are dividing both sides by negative, so here we're going to right away switch the direction of the inequality, and we have x less than or equal to 12 divided by minus 2 is negative 6. Notice when I gathered together the x terms, I do like to bring the x terms over to the left if possible. And that's so that the inequality reads with x on the left in the end. All right. Otherwise, we have to switch the direction of the inequality. Rarely one has to do that. In the previous example, it was advantageous, but in general, I like bringing the x's to the left. Number 10, we have a little simplifying to do on the left-hand side. Before we begin, let's multiply through by that 5 distributive law. So here we have 5x minus 5 times 4 is 20, less than 10x plus 2. All right, and now let's gather together the x terms. Again, I like bringing x to the left, so let's do that. All right, so here we have minus 5x minus 20 less than 2. And now we want to isolate the x term. Let's do the opposite of the minus 20. We're going to do plus 20 on both sides. Let's bring down the minus 5x. And here we have 22. And now to isolate x, we're going to divide both sides by negative 5. All right, dividing by negative, switch the direction. And as a final answer, we have x greater than 22 over negative 5, or I can write that as minus 22 over 5.